Good morning, everyone, afternoon, night, whenever you're being listening to this. My name is Nicholas Bounton, and I'm going to be doing a little tech talk on knowledge simulation and modeling simulation. So first of all, thank you all for being here, either by your own free will or due to class requirements. Either way, happy to have you here. And today we're going to be discussing about the critical intersection between the two major technological disciplines of knowledge management and modeling simulation. The reason I chose this topic is knowledge management is something I think we experience on a day-to-day basis. But I certainly don't feel like I fully understand it. And so I want to take this opportunity to learn more about it. And hopefully through the next couple minutes, you will too. Because as our systems grow increasingly complex, such as it is in healthcare, or really any other technology field you're involved with, the way we handle the knowledge behind our models is almost just as important as the model themselves. Today I'm going to walk you through the state of the art of this technology, how it fundamentally relates to simulation, how it's being used in the real world, and finally, where is this incredible field headed? So let's talk about what is knowledge management. So just by definition, I'll read this straight to you. Knowledge management is a systematic process of identifying, capturing, organizing, storing, and effectively using an organization's collective information, expertise, and experiences. Its goal is to connect people with the right knowledge at the right time to improve decision making, increase innovation, and prevent the loss of valuable insights when there is turnover within the organization. So when we traditionally think of knowledge management, especially in the military context, I think a lot of us are aware of these systems. There's the Mill Suite and whole Mill family, rest in peace. Microsoft Teams is a newer format along with SharePoint. And as you think about these, are these systems, how do they handle large quantities of data? Are they accessible by everyone? I think some of us have .mil and .health accounts, and can you access that? And are they designed in a way that allows you to easily access the requisite data and then capitalize on that? Some healthcare, you can make an argument that some of these types of systems are knowledge management in the healthcare field. Again, asking those same questions. How do you find that information? How do you use it? Where is it stored? So defining knowledge management in the field of modeling simulation, it goes really beyond the raw data. We traditionally think of knowledge management, knowledge simulation, we traditionally think of the link of lines of code, massive computational power, and raw output data. But knowledge management in this context is about the context of the data itself. It transcends the traditional storage of the data. It is structured discipline of capturing the assumptions, the engineering constraints, the human expertise that originally shaped the model. You'll find these types of concepts were similar into our lesson a couple of weeks ago about verification, validation, and accreditation. We're shifting away from simply managing output data to explicitly understanding the why and the how the data came about. Why was this simulation built? What were the boundaries of the conditions? This critical layer of knowledge ensures that the complex simulations can be reliably reproduced, scientifically validated, and safely reused by entirely different teams years after the original teams moved on. So what does the state of the knowledge management look like today? Well, it goes far beyond my simple understanding when I started this project, such as file save, organizing folders within folders. It really goes beyond those simple databases. Today, the leading edge of this technology involves highly integrated intelligent software systems. We're often utilizing advanced semantic webs, which are extensions of the World Wide Web that are designed to make internet data directly computable to computer-based learning to create what's called a flexiformal representation. Again, that's another term that takes human prose, human dictation, human language, and turns it into something a computer can understand. These breakthroughs mean that computers' algorithms actually comprehend the underlying mathematical relationships and logic and not just random text strings. Furthermore, cloud-based collaborative environments are forming a centralized nervous system for the global enterprise of simulation data. You can have teams in Japan, teams in Europe, teams in the United States all work asynchronously or simultaneously on similar models that are being built in real time. So what are the three pillars of knowledge management? First, we have the ontological frameworks. These are structured systems that represent relationships within a specified domain. This is all about standardizing the complex languages used to describe models. It ensures that propulsion systems in one department are seamlessly interoperable with aerodynamic models in a different department. On the most layman's understanding of an ontological framework is you can think of the Dewey Decimal System. How do we organize large amounts of information so that way it's all easily found in the same framework? Second, we have digital twins. These are more than just fancy 3D models. It's really the ultimate knowledge repository. It's simulation that constantly updates with real-world sensor data, bridging the gap between theoretical knowledge and physical reality. And then finally, you have probably what we're all most familiar with is the AI-driven metadata knowledge management systems. These are machine learning algorithms that automatically tag, categorize, and extract knowledge from legacy simulations. This takes a massive burden off of the end user as you're able to quickly sort and utilize information. Some of the systems we use every day, such as UpToDate, Google Gemini, ChatGPT, these are all variations of AI-driven metadata. So connecting knowledge management to model and simulation, how exactly does it relate to the core of modeling simulation? Well, the fundamental link lies in this concept called conceptual interoperability model. Specifically, you see a lot of researchers use what's called the LIMIC framework, the levels of conceptual interoperability model. The LIMIC proves that two simulations to work together, simply sharing data formats isn't enough. They must share the same underlying assumptions about the world. Knowledge management is about bridging and reinforcing that alignment. Without knowledge management, a legacy model is an opaque black box. You have no idea how it was designed, how it was used, how you can use it moving forward. But with knowledge management, the model's constraints and the variables are explicitly stated, transforming it into a transparent, reusable scientific asset. Again, going back to that old lecture talking about, or I shouldn't say old, but previous lecture talking about validation, verification, accreditation is how did we go about designing the model itself, and then how do we use that moving forward. So now that we have a little bit of understanding of the theory, the art of knowledge management, how is it being used today? The applications are incredibly broad. I mean, you saw on our previous slide, of all the different systems that can be considered, quote, knowledge management, end quote, today. But these are just some, kind of some examples that we see in a more modern technological way is in the pharmaceutical industry. They actually have what's called a model-informed drug discovery. The knowledge management systems will store historical trial data. They'll be incorporated with the biological pathways, allowing researchers to accurately simulate drug efficacy, the toxicity, and its side effects long before you ever enter into the actual expensive physical lab phases. In the defense industry, the military, specifically the Navy and the Air Force, utilize platforms such as the Joint Simulation Environment. This is a massive federated system where different defense contractors can plug in their specific wargame simulations into a master environment. The knowledge management system, such as the Joint Simulation Environment, essentially will make sure that Company A's radar works with Company B's airplane and so forth. While in manufacturing, companies use that digital twin that we were talking about to manage entire lifestyle products. I'm a big fan of Formula One racing, and so you see it a lot in Formula One. It's expensive to build these models, to put them through wind tunnel testing, when you can build these in the computer model and have you can actually test the physical parts, stress the real-world application, and get some predictive data back, actually. So why is knowledge management really important? Why should we continue to invest in it? First, from a business side, it's about maximizing return of investment by preventing that constantly, quote, reinvention of the wheel. In large organizations, engineers and teams will spend thousands of hours recreating models that already exist simply because they couldn't find them or they couldn't trust the assumptions of the old ones. Think about how many times you see someone, hey, does anyone have a PowerPoint for this or a PDF or a memo for that? I mean, that's knowledge management on a very basic level. Whereas good knowledge management drastically reduces these redundant developmental cycles and increases productivity overall. It ensures reproducibility, which is the absolute cornerstone of scientific validity, going back to your scientific process from middle school. But perhaps most importantly, it drives safety. Applying a model outside of its original intended constraints can lead to a failed infrastructure of flawed operational strategies. We talked about this in our ethics portion of this course. Knowledge management acts as a vital safeguard against the dangerous misapplication of models. So where is the future of knowledge management? Is the future today? Well, the future is moving rapidly towards an automation and artificial intelligence, specifically a paradigm of agent-directed simulation. I won't go into too much about that category. I refer you to some of my classmates, Captain Coleman and Captain McRoy, who did a whole presentation on that. But in the near future, AI agents have autonomous access to vast organizational knowledge bases. If an engineer asks AI to test a new structural hypothesis, the AI agent will independently search the knowledge base, find the appropriate legacy submodels, compose them together, execute the simulation, and provide the insights. Furthermore, we're transitioning simply away from creating static document save files, and creating dynamic situated learning environments. The knowledge management systems of tomorrow won't be just passive libraries that we're so used to and so comfortable with using today. They'll be active, immersive environments that interactively teach new engineers, new team members how to handle those complex systems. So I'll pause here for any questions. No, I don't hear any questions. Okay, great. I know, tongue-in-cheek, asynchronous, I got it. But in conclusion, knowledge management is no longer just the librarian's task of organizing books, no longer just the S3, the operational officer, the staff officer's job of organizing files. It is a vital technological infrastructure that makes advanced modeling and simulation possible, scalable, and most importantly, safe. As models continue to dictate the future of our physical world, managing the knowledge behind them will be one of our most important technological endeavors. Thank you very much for your time and attention today. Enjoyed working with you all, and you take care.